Hi, and welcome to my video on point slope form. Today we are going to be covering the third and final form of linear functions. We have previously talked about slope-intercept form, standard form, and now we have our third one, point slope form. Just a quick review in slope-intercept form. We want to remember that that looks like y equals mx plus b, and the two things that we can see when we look at slope-intercept form are the slope and the y-intercept. In standard form, we get a function that has the variables x and y on the same side of the equal sign. And without solving anything at all, we can't really see any characteristics of our linear function just by looking at standard form. We talked about how we can easily solve for the x-intercept and the y-intercept in standard form, but by just looking at it, we can't really tell any details. Now, in point slope form, I bet you can't guess the two things you need in order to use point slope form. Or maybe you can. The one thing you need, the first thing anyway, is a point that is on the line. So that is any point on the line, the linear function. And then you also need the slope. This is what point slope form looks like right here. It's y minus y1 equals m times x minus x1. The three things that we end up replacing in point slope form are the y1, the m, and the x1. The plane y and the plane x stay the same. An important thing to notice also is that the form has subtraction signs in it. So these subtraction signs are built into the form. So that needs to be something we keep in mind when we maybe plug in negative numbers here. We'll have to remember to pay special attention to those cases. So let's go ahead and just jump right in. This first example says the slope is -8. The point 312 lies on the line. So we are going to use that information to use point slope form. So the great thing about point slope form is all we need is any point that's on the line and the slope. So in examples like this, when they give you those things right away, it's super easy. We're going to plug in the form, and I'll write it again on the pages as we go so it's fresh in our minds. I'm just going to start filling things in. So first of all, remember my m is -8. And 312 is my x1, y1. So I'll go ahead and label those things. Makes plugging it in even easier. So I'll start with y minus, my y1 is 12, and it equals m, which is -8, and then I'll put parentheses, x, the minus sign, x1 is 3. Then once we plug that in, we are going to put the equation into slope-intercept form. So we want to change it to y equals mx plus b. To do that, that just means we're solving for y. And you'll hear that a lot in this whole unit. So to solve for y, we really only need to take two steps. The first thing I want to do is distribute this -8 on the right side. So when I distribute, remember I'm multiplying. -8 times x gives me -8x. -8 times -3 gives me plus 24. And then my last step is to add 12 to both sides. And that gives me a final answer of y equals -8x plus 36. So I went from only knowing the slope and just a random point on the line to being able to get slope-intercept form, to get the y-intercept also. And now I can also graph it from this point if I needed to. To summarize a little bit, basically our 2 steps for solving for y are to distribute the slope, and then we add or subtract that number that's with the y to both sides. So really only 2 steps. Super neat. Okay, now let's try these two. The slope equals 2/3, and the point that we have is -3, 5. So again, y minus y1 equals m times x minus x1. All right, so I'm going to plug in y minus 5 is my y1. Then m goes next, and that's 2/3. Then I have parentheses, x minus, remember the minus sign is part of our form, and then I have a -3 that I'm subtracting. We talk about this all the time. As soon as I see minus and negative, I'm going to change it to positive, plus plus. That brings us to y minus 5, and then I want to distribute the 2/3. So 2/3 x, 2/3 times 3, 2/3 times 3, like 3/1, simplifies to 2. And then my last step is to add 5 to both sides. So y equals 2/3 x plus 7. If you feel like you kind of want to try one on your own now would be a good time to pause, and then you can catch up by watching my steps afterwards. So for this one, I'll label my x1, y1 again. The process is very much the same every time. So I'm going to write y minus, my y is a negative this time, so -2 equals, and before I go on, I'm going to go ahead and just pop those plus signs in there. Then I write my slope next, -3 with a parenthesis, and then x minus x1, so 4. Now I do my 2 steps. Distribute first, y plus 2 equals -3 times x gives me -3x, and -3 times -4 gives me +12. Then I will subtract 2 from both sides, and I get y equals -3x plus 10. This page of our notes right here is actually just an example, a worked example, if you will. And it's showing you how you would use point slope form from a table. If our table doesn't have the y-intercept in it, then we have to use point slope form in order to write the equation of the line. So the first step we would take would be to calculate the slope. It wasn't just handed to us this time. We got to solve for it. So we would use the slope formula to solve for the slope, and then we would pick any point in the table. So they picked 2, 6, to then substitute into the point slope form. And then from there, we would probably go ahead and just solve for y. So let's try it. Here in this table, I'm just going to pick the points 2, 8 as my x1, y1, and my classes earlier told me they didn't want to use the number 13, so we're going to pick the 0.618. Guess it feels better. So first thing we want to do is solve for the slope. Remember the slope formula, y2 minus y1 over x2 minus x1. So for this one, I take my y2 is 18, and then my y1 is 8, so subtract 8 over x2, which is 6, minus 2. 18 minus 8 is 10. 6 minus 2 is 4. I can reduce that fraction a little bit. Both of those numbers are divisible by 2. So I can simplify that down to 5 over 2. That's my slope. Now I'm going to use x1, y1 again in point slope form. So point slope form for the fourth time looks like that. I'll start replacing as I write the form. So y minus y1 is 8. Now if you wanted to pick a different point, that's okay. If you wanted to pick a different point, that's okay. But I'm just going to use the one I labeled already. So y minus 8 equals, and then here's where I plug in that slope I solved for, 5 over 2, parentheses, x minus 2. Now let's solve to get that solved for y. So distribute the 5 over 2, and that gives us y minus 8 equals 5 halves x minus 5. 5 halves times 2 equals 5. Then we'll add 8. Y equals 5 halves x plus 3. So that would be how we would go from just seeing a table to being able to write our linear function. We would use point slope form.